Hello, and thank you for watching the continuation of our discussion on wave-particle duality, particle physics, the Institute of Knowledge and Research in Science. Our documentary is still continuing on this interesting series of particle physics. Please Google TIOKRS, the Institute of Knowledge, to visit our website on intriguing facts on science. So now we shall move on to the photoelectric effect. Well, the photoelectric effect. So where shall we begin? That is about light being shone onto a metal surface and the electrons being discarded, liberated from the atoms off of the surface. First we shall begin at the look at the atomic structure. Well, after Rutherford suggested the atomic structure of how electrons orbit the positive nucleus, it then came to the scientist's mind that this was quite contradictory to the knowledge known about atoms, simply because if electrons were accelerating, since they were charged particles, they must be radiating electromagnetic energy, and in radiating energy they would lose energy, and thus they would gravitate towards the nucleus through electrostatic forces. So the scientists were not too pleased with this, but Niels Bohr suggested that actually electrons could only orbit in particular distances from the nucleus, and that they couldn't orbit in between these gaps. So they have particular energy levels at which they can orbit. So the first orbit was known as the ground state, which requires 13.6 electron volts of energy to be liberated from the atom. The next energy level was known as energy level n equals 2, which requires 3.5 electron volts to be liberated from the atom. And then you go on, which requires less, each energy level requiring less and less energy for the electron to be liberated from the atom, up to n equals infinity, which requires no energy for the electron to be freed from the atom. So, looking at this photoelectric effect of which is light being shone onto a metal surface and the electrons being liberated away, it was postulated by Max Planck that light doesn't have to only be thought of as a wave, but also can be thought of as packets of energy, quanta, known as photons. These photons have energy of the equation E being energy equals hf, h being Planck's constant, an extremely small number, and f being the frequency of the light. Different frequencies of light produce different colours. So it is thought that the photoelectric effect can be explained by these quantas of light, i.e. the photons, being absorbed by the electrons and the energy being used in the electron to be liberated from the atom. The amount of energy required for an electron to be liberated is known as the work function. The nearer, as I said previously, the nearer the energy the electron is orbiting to the nucleus, the more energy is required for the electron to be liberated. So this means that you'll need a higher energetic light ray to liberate the electron. So it's now we have that the energy for the electron to be liberated from the atom is known as the work function. So if we want a photon of light to liberate an electron, it needs to be either equal to the work function or greater than the work function. If it is greater than the work function, the energy of the photon will be absorbed by the electron, and the excess energy will be used as kinetic energy of the electron. So the electron will leave the atom and have kinetic energy. If it is just equal to the work function, the electron will only be liberated from the atom, and that will be it. If it's slightly under the work function, the electron can rise to a higher energy level, if such an occurrence occurs, this is known as excitation, where an electron goes from one energy level to the next energy level. After a while, the electron goes back down the energy level, thus releasing a photon in the process of travelling back down to its original energy group. the frequency of the photon that it releases is exactly the same to the photon that it absorbed, and it is also the difference between the energy released is the difference between the two energy gaps, the two energy levels that the electron just travelled from, and that is E is equal to HF. So when an electron is liberated, that is known as an ionized particle, because it now has a charge, a more positive charge. Other aspects of the photoelectric effect, well, we can look at line spectrum, absorption and emission. When light travels through gases have different gases have different electron arrangements, and so thus their electrons absorb different lights of different frequencies, because their electrons require different photons at different frequencies to absorb. So when light is shone through a gap, there are dark lines that appear because the electrons in the gas only absorb the different frequencies of the photons. And also the emission is a similar but opposite process, where the electrons have been excited, and in coming back down they release the particular light rays, which are the opposite, which produces the opposite pattern of its absorption spectrum. Other discussions we shall be having. Oh yes, X-rays. X-rays is accelerating electrons to high speed, and then they collide with, I believe, a metal surface, which, yes, and as they collide, they decelerate. In their deceleration, because it's a charged particle, it releases electromagnetic radiation, which can be visible, so allows us to see inside people's bodies and to see things that our eyes will not allow us to usually see through the naked eye. Another medical physics application is the positron. I think it's carbon-11 is consumed by the patient. Carbon-11 is radioactive. It follows the patient's blood, and it travels along the blood, and it goes to the brain. In the brain, and parts where there are high blood pressure, the carbon-11 decides to decay. As it decays, it releases a positron. In releasing a positron, it immediately reacts with an electron, its opposite particle, and annihilates, releasing gamma rays. So it is highly visible to notice where high blood pressure is. This is useful as the patient is doing different activities. The brain surgeons can see what part of the brain has high blood pressure, i.e. what part of the brain is being activated when the patient is reading, sleeping, watching television, or different activities it could be doing. Thank you for watching this interesting documentary on particle physics. Please Google tiokrs for more interesting facts on different sciences and mathematics. I shall shortly be uploading information on other physics, mathematics, biology, cell, DNA, RNA, cell replication, mutation, and different interesting topics. Thank you. Have a nice day.